So, good afternoon, everybody. I'd like to welcome you to the March Open Cybersecurity Alliance Indicator of Behavior Subproject meeting. I'm your host and chair, Charlie Frick from Johns Hopkins Applied Physics Lab. As always, we're grateful to have those of you that could make it with us, and we are recording this meeting to get it up on the YouTube channel so folks that might not be able to attend right now can watch the video later when they have time. And I wanted to start with sharing some, news from the project, and then we'll have a short technical talk, and then kind of open it up for group discussion. But some of the news that I wanted to get, out there first and foremost, I know many of you are participating in the Open Cybersecurity Alliance's CASP, the Cyber Automation Subproject, their Automation Village slash Plugfest. That'll be coming up in April. And we here at IOB have been working for a while on a indicator behavior sample that represents living off the land techniques that we've seen in Volt Typhoon campaign. And very happy to say that we've got the draft of that bundle done. And part of our tech talk today will be sharing some insights from there. But we're still working on the full release process to be allowed to upload the JSON to for the CASP so everyone can have a copy of it. But we have been getting some feedback from other people working to build some demos for CASP, and have been sharing insights and trying to incorporate the changes and requests that people have for those. Also, another thing that I'm really excited about is, so we have Linda Beverly here from the CTA, who's been coming to the meetings lately. And hey, Linda. And we've been having some chats. And so I'm really happy to say that the IOB project is collaborating with the, excuse me, the Cyber Threat Alliance. For those not familiar, Cyber Threat Alliance has members that span a large swath of the cybersecurity vendor community, where they ingest indicators of compromise, where every member submits a certain threshold to maintain good standing, and that provides a very robust, up-to-date source of indicators of compromise for a lot of these vendors to be able to use in their products and services. And in our chats with the CTA, they're interested in supporting indicators of behavior as well. So we're very, very excited about that opportunity to be able to help share the reference implementations, design and development guidance, and overall just collaborate on ways to help drive forward indicators of behavior. Because that type of support on the back end can really be a force multiplier that's going to enable, it makes it easy to use the open standard to incorporate this concept into pretty much every cyber tool on the market. And so pretty big news. And we're grateful to be able to collaborate with Linda and her team. And some of the development projects you've seen from us, we're looking at ways to be able to share, consolidate, and move some of those things forward. So stay tuned as we get more developments there. We'll be absolutely sharing more of that through the listserv and the chat and through these meetings. Another bit of news we wanted to make sure we kept everyone aware is we are still from some of our previous meetings, I've talked about this, but we're partnered with the Hudson Alpha Institute for Biotechnology down in Alabama to do a pilot with indicators of behavior. And we are well underway building infrastructure here at the lab to emulate some of the threat activity for the pilot, and are working on developing those bundles. That'll probably be a little bit closer to summertime when you get to see some of our more shareable findings from that effort. But wanted to keep everybody in the loop on that. And the other bit of development news is just sharing some of the other research that we're working on. We are, from a few meetings back, I think you might remember, or you might be able to find on the YouTube archive, we gave a talk about dynamically finding new behaviors through network traffic analysis. And we are well underway some of our research to do that at a much larger scale to show how you could let automation identify emergent and define existing behaviors, so that the whole idea there is to be able to take a machine learning and artificial intelligence approach. And I have somebody trying to get into the meeting, so I'm going to send them the link. One moment. And as I was saying, I think that it'll take a little bit, but we'll have some neat stuff there where you can really start feeding AI and ML to not just share the threat behaviors and detections, but also start letting it identify new ones. And that's something that we've all said we're probably going to need pretty badly when you want to scale this concept out. I'll pause for a second to see if there are any questions on any of that. Fair enough. Then for today's technical talk, we're going to do a deeper dive into what's inside the Volt Typhoon Living Off the Lab land demo in CASP. But based on some of the conversations I've had with some folks in our community over the last few months, I think there's a also tiny other topic I want to talk about, because as you take this type of threat intel, one of the keys to the IOB concept is that we're sharing a knowledge graph. And we've been using graph databases. In a lot of our examples, we're using Neo4j, not meant as a full endorsement, just saying that's a graph database we're familiar with and we were using. And I think there's a challenge that happens to a lot of folks as you start going at scale when you're processing all this data that makes it very difficult for them to, handle it. And one of those big issues is the data duplication problem. And so I was going to do a tiny little talk on that and then transition over to show you guys the living off the land example and go into some of the detail of what you're going to find in there. So let me share my screen and then find where all of my Zoom windows went. Okay. And just working to get the chat window back up in case people have questions for me. But hopefully you're seeing what looks like a bunch of little colored dots on a black background. I promise it'll get a little bit more interesting. So what I've done here is, you guys might not be familiar with it, but if you are, the Cybersecurity and Infrastructure Security Agency, or CISA, who sponsors a lot of our IOB work here at the lab, they also provide a threat intelligence feed known as Automated Indicator Sharing, or AIS. And we've been receiving AIS since its inception. And I thought that it'd be good to show some of the data scalability challenges by taking a snippet of the AIS public feed. What you're looking at here is, and you're not seeing all of the information, but I took about 1 week. So I've read about 7 days worth of STIX objects that came out of AIS and just loaded them up into a graph database with our little Python script, one after the other. And what happens when you do that is sometimes some of these nodes are duplicates of each other. But additionally, we'll zoom way in, you can see a little thing happen here where, so here's an indicator that's got some opinion objects. And you'll notice this object relationship is getting repeated. And because sometimes there's updates to a report in a feed and the same element shows up more than once. And with STIX's ability to have implied relationships as well as explicit ones through the ref or refs field inside a STIX object, processing those things can just keep adding more and more objects. and more relationships, and sometimes very duplicative ones. And now this is just, like I said, 7 days worth. But, you know, you can take some logic to pretty much, as you load, do some batch processing on the graphs to basically exclude repeated data objects from being added to your graph. So this part isn't too exciting, but you take that same sort of feed, and now, you just have the single relationship. And the reason you care is really comes down to just a big numbers game. So in that original case without the data deduplication, we were, after 7 days, that was about 10,000 nodes and 13,000 relationships. But when you really want to understand how much of that was really duplicate data, we can execute this real quick. And now that drops to 7,500 nodes and 5,000 relationships. And that relationships is the really big problem, because still, in the grand scheme of things, this is a kind of pretty small data set that I was just showing you guys. But you see, like 2/3 of the relationships were redundant. And that's just 7 days. As you go over more time, and when you start thinking about repositories that are going to have millions of elements, you start getting into billions to potentially many more relationships that can really hurt your analytics. Patrick, you have a question or a statement?
Yeah, are there any additional properties in those relationships, like temporality? Is it just that another assertion was made at some later time, or?
No, what causes a lot of them is because the STIX standard, you can define a relationship with traits, but also when you make an object, you have a field where you can have an array of other STIX IDs that have an implied relationship. And so when that object gets repeated, all those implied relationships are repeated upon load.
Yeah, okay. So what this is one of those dreaded multiple ways to do the same thing.
Yes.
Okay. Go ahead,
Which
sir.
go, oh no,
I just thought there might have been some temporality elements to that.
no,
Thank you, sir.
which would be and I absolutely agree with you that that is a case where you don't want to lose the relationships. But the temporal aspect, unfortunately, also kind of gets lost when you take the inferred relationship approach. But since STIX can support both, you've got to be able to, represent them. Now, I just wanted to get that through because, do you have another question, Patrick? Or was you, never mind. And not singling any of us out, but those of us that work with a lot of threat intel platforms, we understand this. This is data deduplication is a really big challenge. And sometimes when you might want to take that even further for when you've got the same intel being provided by multiple feeds. But I know this has been one of the bigger challenges for a lot of people as you start scaling out. And for those not familiar with it, I thought it was important to show that it was a element that can happen when dealing with STIX. Now, the reason I care about all this stuff is I can take that same big ocean, even the deduplicated database, but the reason why we're pushing for these types of things is I can search for IP addresses, and I can search for domain names, and I can get thousands of them. But if I really want to think about behaviors, I'm trying to learn and find more repeatable analytics and get the context. I don't just want a page of 10,000 Sigma rules. I want to better understand what they do, what they're detecting, how I correlate them, and what I do about it if I get a correlation. So it's a little bit more complex. And what's nice about the graph representation is, this might be a little hard to read, but I'm saying here, like, essentially the standard pattern that you'll see in an IOB bundle are that there are attack patterns that have some relationships to our behavior objects, that have relationships to our detection objects, that tend to be grouped together, that have a relationship to a course of action, normally for correlation, and our courses of actions have playbooks. Well, out of that big ocean of data, when I start looking for information like this, I can now turn that down into something a lot more manageable. And so this particular, the one I had in that kind of big data lake was an older version of our Volt Typhoon bundle. For today's deeper bit of the technical talk, I'm actually going to update this. Our team's been working pretty steadily on this, and I actually have a newer one that got loaded this morning, so I'm going to use that. And this will be the bundle that we are looking to share at CASP. I'm going to make this a little less, not much less ugly, but a little less ugly. So I will, and then explain what I'm looking at. So we'll have some detections. Promise this will make a little bit more sense in a minute. And so the dark blue are our behaviors, the light blue are our MITRE attack patterns, the red are our detection analytics, and then green is how we group these together. Then that'll lead to a course of action for correlation, and these light purple are our playbook objects, where we have some examples, and I'll show those in just a moment. But I thought it was important to take you guys through especially for those that are interested in what we're planning to bring to CASP. We were calling it a living off the land bundle. I know there's a massive debate in some of our projects on, do you call it Volt Typhoon? Do you call it something else? We base this off intel from the Volt Typhoon campaigns, but also I'm not here to get into any large geopolitical or philosophical debate on anything. I'm trying to talk about patterns of threat activity that we're going to detect. And so we're calling this one a living off the land example. And in the notes, you can even see we still reference Volt Typhoon in there. But I wanted to show you what we're focusing on, because we want to look at the chain of behaviors that will enable detection. And the first thing I want to say, you might notice if you can read some of this, and I'll try and see if I can blow it up a little bit more. But we're looking at a computer generating a infected victim, generating file hashes, loading up PowerShell modules for conducting reconnaissance. Probably should have flipped these around, but executing some remote commands after doing its reconnaissance, making copies of a NTDS database file for credential theft, and then starting to have new RDP sessions with valid creds across the network and some log deletion. These are all behaviors that have been identified from Volt Typhoon. One thing that people that have been reading a lot of the reports might notice is we did not include initial access in this. And that was intentional. There is multiple reports that say that out of the thousands of Volt Typhoon compromises, in fact, I think there's only one, maybe there's more, but I've only seen one documented case of a zero-day exploit of a particular vendor appliance in a small office, home office environment. And we've seen a lot of breach emulations and threat reports saying, oh my gosh, Volt Typhoon is always a zero-day exploit. And then we start getting into a big talk on zero-day exploit detection. And really what we're trying to get at here with indicators of behavior is yes, it would be wonderful to detect the very first step of everything, but really we want to see is threat activity occurring in your network through multiple observable behaviors. We're not going to have a perfect analytic for zero-day detection. There's also initial access brokers, traditional spear phishing, cred stuffing, and dozens of ways that the first foothold happens. We have a much larger philosophical debate on that, and I'm happy to have that debate with anybody. But we thought it was more important to just say more of a kind of zero trust mentality, and let's just assume that someone has gotten a foothold in the network because they're doing a pretty good darn job showing that they can get that foothold through a variety of methods. And so, and also you'll notice we're not talking a whole lot about malware or, you know, what are crypto mining or launching ransomware payloads, because what we're seeing is they can often exploit normally some edge of a network to get some access of some kind. And they normally steal local credentials off that machine in the attempt to get to an administrator password, normally through password cracking or other techniques. And you're never going to detect somebody running a password cracker on their own infrastructure. So let's look at how the process is when they get generating the file hashes and see if there's anything unique there. Look for loading up of reconnaissance payloads. And a big one that does happen quite often in Volt Typhoon is they'll eventually pivot either through WinRM or some other techniques or RDP even, but they will remote into an Active Directory server once they've gotten some sort of admin cred to steal a copy of the NTDS database that holds all the usernames and file hashes. And from there, they can steal lots of different creds and normally look for accounts that would have access to operational technology and begin to log in and maintain access. And frequently, they're deleting their logs. So this is really the chain of behaviors that we thought were important to include in this first bundle. We are going to refine this as a little bit later date to include a few more things, particularly the establishment of rogue VPN tunnels, because that's a pretty repeated behavior that we've seen, as well as a few things to identify the not just the RDP access, but some of the other file like potential exfiltration and of data. We're still cleaning up some of that, so we won't have that in time for CASP, but these are all the first chain of behaviors that we're going to do. And I'm going to go more into the detections. As always, I do find it's valuable to reference MITRE ATT&CK. I do think that these attack patterns help us understand what's similar between multiple campaigns, but we're not getting quite enough out of these to do our full detection. So that's why we made behaviors and make our detection objects and our correlations. That said, I thought it might be good to also show you what we're talking about for the detections that we're going to generate. So I will show you some of those right now. And I'm going to try to blow this up. But so we're coming back to the fact that last year we used Stick Shifter. Traditionally, a lot of our examples, we like to use Sigma rules as well, but basically different ways to translate a threat detection analytic across multiple infrastructures. Because one thing that we definitely believe strongly in is that we have to look at sharing these defenses across a community, and we really, really can't just all assume we have vendor A and only share vendor A's analytics or vendor B or whatever, because we're just not going to make the entire world all go by one vendor's vertical stack of products. So we've been working to utilize Sigma, and we're still using a combination of Elastic Common Schema and Splunk Common Information Model. Another stretch goal for our team, but there's only about 5 of us, and there's a lot to do. But we are trying to learn open cybersecurity schema framework as well, and trying to follow that project. But what you'll get in the bundle we're providing for CASP is for each behavior, we'll have a Sigma analytic. As some of you may be aware, we are still currently looking for leads to maintain and kind of guide the Stick Shifter project. So we weren't going as heavy into Stick Shifter right now as some recent mergers and acquisitions over the past year. We have support, very grateful for it, of people to maintain the current code base on GitHub for Stick Shifter, but there hasn't been a lot of new development for about a year. And so we thought it would be more handy to have some of the Sigma rules. So as we go forward in the CASP Plugfest, if we had different environments that we wanted to test detections with, these can translate pretty quickly. But so we'll be including all of these just so you get a feel for what they would look like in the sticks itself. I'll go back to this little example. So those of you that are familiar with our previous reference implementations will know this already, but we include detection objects for each behavior. It's all well defined in the spec and the technical documentations on the IOB website on GitHub. But essentially, the detection objects include an analytic field that will tell you the type. And we're big fans of base64 encoding things like Sigma rules because white space gets translated weirdly across different tools. And so having a base64 string that just spits out the analytic in the right formatting, we thought was pretty key. And so you'll always be able to get those by extracting the rule part out of the analytic. And if somebody does wish to include an analytic in just plain text or as a SQL query or as a Splunk search or an Elasticsearch or a Sumo Logic search, you can define that type as pretty much anything you want. So you just need to be able to identify what it is, and then you can embed it. Now, that's all fine and good, but another thing that we've also pushed hard with IOBs is any one detection by itself might not be terribly indicative of a threat. Even here, there are lots of tools that generate WinRS commands. Now, we are trying to, in this particular analytic, we're looking for some processes spawning off new PowerShell and Windows Command Shell, so it's a little bit different. But we really need to see how we can correlate it. And so based on the feedback that our community has given us over the last few years, we got rid of the detection grouping object and use a sticks grouping object that now has a relationship to a correlation course of action. And that correlation includes encoded Cacao and BPMN playbooks. So I want to correlate these alerts. I can say, let's see. Well, I'll show the BPMN and then I'll show the Cacao roaster right after. So I've got a playbook Ben field. Yep. So I can actually copy that and God help me. Hopefully I did that right. We should get a ton of stuff dumped on the screen. And I won't make you watch all that. But I can take that to a base 64 decode and dump that to a file that's already done. I did this right. This ought to come up in just a moment. Yay. And now I've extracted that out and I can see this correlation process that we're recommending here of essentially when any one of those detection analytics fire, they can start this process to basically begin checking all the other ones and asking some pretty simple decision logic of, is there something here that lines up with one of the other alerts that could have happened throughout that day? So kind of a very SIEM-centric search, but EDR, other solutions can take this same logic and approach, depending on what type of data and data sources they're grabbing. Then essentially tally points for the event, and basically when they process a threshold, saying like, in this case, if only one alert if only got one particular point, this workflow would stop. If you go more than that, say that we can have low priority cases that could be a daily digest that somebody looks at the end of a shift. But if it gets over 3 points in this example, we'll make a high priority ticket saying, hey, we've seen these 3 alerts correlated amongst these elements of the network. We think that we have successfully found something potentially bad. And so, and as I said earlier, we also have we also have done this in Cacao. And I'm gonna really tempt the demo gods. And meant to have Cacao Roaster running before but it starts pretty fast. And I'm going to just get rid of that little line from the Neo4j. Normally you just extract this directly out of the JSON object or whatever sticks you want. But if we did this right, and I could fail very much because I haven't tested it, but we have that same correlation logic essentially defined in Cacao Roaster, and we'll have that all available. And I saw Mateus out here and Vasilio. So again, thank you guys so much for the work that happened on Roaster. And Tim on our team went to great lengths to make sure that we got the green valid playbook button as we made these. So that'll be included in there as well, so that if we're for CASP, we can take advantage of these different tools. And we are doing, we don't have this working on Sorka yet, but that's another tool that's been running off Cacao using OpenC2. And that is an area that we're actively doing some work to be able to take advantage of to do the correlations, to try and just embrace the value in OCA of the open standards and interoperability. So I know that was a lot that I just kind of verbally dumped out there. I wanted to take a moment and see, are there any questions about what we're planning to bring to CASP, things that you might want to know about what's in there, what's not, and I'll be happy to answer any questions if anybody has any. Okay. Well, if we don't have any questions, oh, okay. And thank you, Vasilios. I see that it's looking like the Cacao Roaster integration with Sorka should be coming soon. We're really excited because I know a lot of our team, we've been having some nice talks with Costas out in Europe, and we've been working on the GUI for Sorka, but I really like the integration of Roaster and Sorka together. Patrick.
Hey, everybody. I'm glad I was finally able to make this call after many months of conflict. So hello, everybody, and thank you, Charles, for all the work you're doing here.
Absolutely.
Coming into the live dialogue on this, has anybody tried mapping the IOBs into the Radical type DB yet? Or is it pretty much just what we're doing here with Neo4j?
So we've been in a lot of calls with the OS threat folks and that are out in the EU and Australia,
Okay,
and they've been working on a release to take IOBs and put them into type DB. And I've also been talking with Callum over there at type DB, talking through this idea of how we process this. We haven't written a parser yet from stick, because really, I think if you're going to do this, you might as well just do sticks to type DB rather than IOB to type DB, because it's the
Yep.
same approach.
Agreed.
And
And
so
that's what I've done with varying degrees of success myself. So I agree with you.
oh, fantastic. Because yeah, so
Okay.
really we brainstormed what it would look like, but we haven't written the code yet to map to a type DB infrastructure. At least on our team's project.
Okay,
But
so
it's an area
none of
that
that's public facing at the moment, Charles.
correct.
Okay, and who was doing it again?
The people that are doing the research is OS Threat, Brett, don't remember his last name at this second, but there's been a few of them participating. They've been pretty vocal on the IOB Slack and
Thank you, sir.
and we are watching with bated breath for the release because I think there'll be some interesting capabilities there.
Thanks, sir.
Oh, sure. No problem, Patrick. And did somebody else have a question? I think I saw something either flash on the chat or come up, but I just couldn't see it fast enough. Okay. Here, I'm going to stop sharing then for a moment. And
it looks like Vas has something in the chat here.
Yeah, Vasilius, it looks like you have a project connecting Roaster Sorka and introducing a knowledge management system. And that could be really interesting. So definitely looking forward to some of that discussion. And I don't know if you're able to come off mute if you wanted to speak to that, or you don't have to. I just wanted to make sure I gave you an opportunity if you wanted to.
Yeah, sure. I just shared also the link. I hope it works. I just copied so fast. So yeah, you can see the research that we did there, and then we're also going to open source the whole project. Nothing special, but it works fine.
Is it, since it's your project, I wanted to ask, is it okay for me to share the screen?
Yes, absolutely.
Okay,
absolutely.
Well,
yeah,
I like to check with folks before I broadcast their stuff onto YouTube.
Yeah.
Now, I might have a problem on my firewall because I imagine this loads faster. Oh, okay, here we go. Excellent.
Yeah, and then you can remove the markdown, right? When it loads, you need to recompile. I assume you didn't. If you click the recompile button at the right side at the top.
I'm looking.
A little left. Yeah.
There we go. Oh.
So yeah, and if you go down, I mean, what matters are basically the screenshots. Let's call them. Let's go down. Right, because this is an academic application, we need to have also the right literature.
Absolutely.
Yeah. So well down.
I'm getting there. Here, let me.
Yep. And of course the architecture, but what is important, at least for now, is go a little down when you're ready to.
Is this where you want me to go?
Yeah. I mean, you can see the basic architecture, but then we have concrete screenshots from the tool and what's going on and what we'll have the ability to experiment with. So it's nice if we can integrate. We have also integrated Taxi as a sharing component.
Oh, nice. Yeah. Is this the?
Yeah, that's a basic front end. But I think you are going to like the KMS capability. So go, yeah. And if you can start zooming in, then you'll see here, what we have. And of course, we have multiple screenshots.
I'm
So
trying
we're keeping track of the execution of the playbooks.
Oh,
So
did-
yeah, it
I-
was the other one. So
you're
yeah,
learning
good, this
how,
one. Yeah, and then basically you hover. You see the three.
I am this.
Yeah. So
Okay, we're just gonna keep going.
exactly.
Because
Okay,
apparently
okay.
I'm
Yeah.
incompetent.
No worries. So, and if you go lower, you'll see that we have also execution details. And somehow you succeeded to make the document that recompile it.
You know,
Mm.
my incompetence knows no bounds, good sir.
Yeah, we can see. Yeah. So
Okay, and so now we can see.
maybe you need to zoom out a little right now. Yeah. So you can see some statistics, right? The monitor page.
The execution, like tracking how it's executed history.
Exactly.
So a lot of your, more fully featured SOAR capabilities.
Yeah. So we have API performance and how it scales, etc. So
Cool. This will be really exciting. I like it.
yeah, and most importantly, we have also integrated Taxi with collections. So basically, you can exchange your playbooks through the platform by creating communities, and it will become open source. I mean, the code is available. I think Mateus is doing some kind of refinements now with another guy, so it should be published tomorrow or the day after tomorrow, and Mateus can confirm.
Fantastic.
I think, yeah, he's here. Yeah, so
Cool. So yeah, I'm excited. So yeah, pretty much that's what I had for, I know a few minutes early, but these were the big things I wanted to kind of go over because I know we've been talking a lot for some time on what we were going to build, and I thought it was important for everyone to get a chance to see it, or at least I'll have the recording on YouTube as soon as possible so that other folks from CASP, because I know getting all of us together at one time and place is a real challenge, but I wanted folks to be able to have some idea of what we're planning to bring so that if you wanted to integrate with any of it, we can help make that happen sooner rather than later. So with that, I'll open the mic one more time for open discussion if anybody has any topics or questions they'd like to ask. And I will take that as a no. Oh, Jane, I'm sorry, you came off mic. Did there something?
I just wanted to say thank you. This is really helpful. And this will, I think, play an important role in that morning session and afternoon session on day one.
Thank you. That's what we were shooting for. And so with that said, I think I'm going to stop the recording and welcome folks to find this on YouTube when I send out the link, and we will see you at CASP for those that are attending, and for the others, we will see you in June for the next quarterly meeting. But with that, I'm going to stop the recorder.